Hey all, welcome back to my channel Hierarchy. Every problem in this world, we have a solution. So, if your problem is handling complicated data and understanding what is going on inside that, you need to definitely understand how this library works. Today, we are going to see a library called ggplot. So, for working with this library, first thing what you have to do is you need to install the libraries. So, first of all, what is ggplot and why do we need this? In our programming language, we have something called ggplot2. It actually follows grammar of graphics. Data scientists who got inspired by that, they developed a library in Python called ggplot. It is something that you could import and use from plotnine modules. So this is actually a library which is used for creating amazing visualizations. Instead of saying draw a bar chart, if you say here is my data, map variables, add layers, apply statistics, apply theme, then this is a go-to chart. So specifically why people often choose ggplot style in Python, because it gives us structured and logical answers, because the layers build on each others. It is specifically reusable and it is statistically meaningful. And whenever I do want to create charts that is easy to read, if I understood how this actually works, then definitely you should be using and you should know about ggplot. Let's get started with how to work with this chart. So the first thing that I'm doing is I'm installing this plotnine module into my coding environment. Followed by that, these are the libraries that I need to import: pandas and numpy for handling data. Then from plotnine, importing all libraries because I'm going to handle the data and create visualizations. From plotnine data, I'm importing my data set MPG. The next step that I'm going to do is I need to install scikit-misc. This is specifically a module which has data analysis tools which we could use as a library for our coding environment right now. The first chart that we are going to see is layer-based statistical chart. So what this chart is, first of all, layer-based statistical chart. This is actually a chart which has multiple layers that are stacked below one another. If I have a raw data, if I have statistical summary, and I want my chart to show me both. I want to see raw data and also the statistical summary. Maybe it might be mean, median, or mode. I want to see both in my same chart. Then I should be using layer-based statistical chart. That is why it is called as layer-based statistical chart, because you are layering both the raw data and a statistical value of it. Now it's time to understand how this coding works. The first thing is ggplot. This is where we are creating a ggplot object. Followed by that mpg, it is actually a data set. In x and y axis, I'm plotting the column names. So here displ is actually the column name, engine displacement, and hwy is a highway mileage. When I give plus geom_plot alpha, which is equal to 0.6, it adds scatter plots to my plot that I'm going to create. Here each point represents one core in my data. Alpha is equal to 0.6. It is about, I'm creating a scatter plot, right? In that I do have scatters, that points. I am mean that transparency should be 60%. So it should be semi-transparent. That is what I am giving as 0.6 when I give alpha is equal to 0.6. Followed by that, I'm giving plus stat summary. It is actually adding a statistical summary layer. Followed by that, when I give fun y is equal to np.mean, it applies the mean function to my y-axis values. I mean that HWI. What is HWI? First of all, it is highway mileage. Then what I'm doing here, followed by that, I'm giving geom is equal to line because it displays me the calculated mean values as a line. Then I'm giving color is equal to red because it sheds the color of the mean line to red. Why I'm giving size equal to 1.2 here? Because I want the thickness of the line to be more than usual. That is why I'm giving 1.2. Followed by that, I'm closing it and then I'm giving plus labs. It is actually the labels that I'm going to create. The titles, then the title of the chart, and mean what I need to give in x-axis, then what I need to give in y-axis. Now it's time to look into the chart, how it looks. See. Here, the dots represent the raw data and the line represents the mean values line. So that is why I am telling if I want to represent both the values, raw values and also the statistical value, I need to layer both. Then I need to use this layer based statistical chart. The second chart that we are going to see is smooth regression line. What is this smooth regression line? How it works and what is the purpose of this chart? So specifically why I need this chart. Here LOESS. What is this? It is the meaning, the meaning of this is locally weighted smoothing. So it is often used for a reason if I want to understand the relationship between X and Y. So it specifically ignores the small fluctuations. It actually creates a smooth curve. So in which scenario I need this chart and when I'll be applying it. So if my scenario is like I want to find the relationship between website traffic and the time, in which time most of the people are visiting my business website. If that is my goal in that scenario, I need to use this chart. So in such scenarios, where and all you could use the chart. If I want to see based on this month if rainfall is increasing or not. So based on time, I am trying to understand if my value is changing. So in that scenario, I need to use this smooth regression line. Now let's try to understand how the coding works. The first thing is I'm using ggplot because I'm creating that plot. Then MPG and AEX, this is almost similar to what we have seen in the previous chart. Then I'm giving geom point alpha is equal to 0.5. Here I am changing the transparency 0.5, transparency to 0.5. Next is I'm giving geom smooth of method is equal to LOESS. Why? Because I'm going to create a line that fits a LOESS regression model. Here, this particular regression model is used for capturing the non-linear trends. First of all, what is trends? If my data differ based on timeline, it is called as trends. Then what is non-linear trends? Linearity means if a column and another column has a relationship, that is called as linearity. If it is not having a relationship, it is called as non-linear. Now, we have non-linear trends to understand through this chart, right? So it says that if my data doesn't have any relationships, but it has changes over time, in that scenario, I should be using this chart. Here I am giving color is equal to blue because the line need to be in blue color that you can change as per your test. Then I am giving plus labels because I am going to give the label here, and finally after giving all these things, the charts will be created like this. See, the line's color is in blue, and along with the line we have a smooth curve that got created. So this smooth curve represents the regression line, LOESS regression line. So beautifully we are trying to understand the relationship between highway MPG and engine displacement. That is why we are using this chart smooth regression line. The third chart that we are going to see is density ridgeline plot. Why I need this chart and in which scenario, in which places I'll be using this chart. The first thing that you need to keep in mind is this specifically creates multiple charts. When I try to create a plot, it is going to create multiple plots. It is going to look like mountain ridges. So it shows us the distribution shape and it compares across categories or time. So in that scenario, if I want to compare the salary of employees based on experience, salary of employees based on their technical expertise. So in that scenario and all, I'll be using this chart. Now let's try to understand the coding part. Here what I'm doing, first thing is ggplot is as similar to the previous one. The one thing that differs here is I'm giving fill is equal to class. So this class is specifically for controlling the fill color option. I'll be creating multiple charts, right? Everything will be of different colors. To control the color, I'm using fill is equal to class. It will be classifying it and using it accordingly. Then I'm giving plus geom density. Alpha is equal to 0.6. This is something. It avoids overlapping densities which need to be visible. Then I'm giving facet wrap of class and NCOL is equal to 1. So what specifically is the NCOL is equal to 1 here? If I want my panels to be stacked vertically, then I need to use NCOL is equal to 1. So this one is about creating the charts in a vertical way. One chart, then the second chart, then the third chart in a row wise manner. It shouldn't be in a column wise manner. It shouldn't not be on the right side. Instead, one chart below that I will be having another chart. Then I'm giving plus theme because it begins the custom theme settings. Then I'm giving the figure size, the whole figure size. I'm giving 6,10. So it could be completely customized as per your requirement. Followed by that, I'm giving subplot suggest. Headspace equal to 0.4. So here I'm creating multiple charts in a vertical way, right? So in between every chart, I need to specify the space I need to see that clearly. So I'm giving 0.4. So you can even give 0.7 or 8 if you want the space to be more, the space to be big. Then I'm closing this because I completed the process. Then I'm giving labels and then I'm giving the title and in X and Y what I need to plot. This is what I'll be doing next. So let's see the output of the chart. See, it created multiple chart as I already mentioned and everything is of different color. So the class that I've given here fill is equal to class is because I want every class of different color. So it could be easily categorized. I can easily understand the data. That is why I'm giving in this way. So see, this chart is too professional, right? I have a colors which looks too professional. Then I have a line that easily helps in differentiating between one and another chart. The space that I could specify, I can categorize. I mean, I could easily customize it and I could give as per my requirement. But the lines coding that I used for creating this chart is very less. So this is almost similar to the previous chart. So this is something that we wrote for creating this beautiful chart. So that is why ggplot is often used for creating professional visualizations. Most of the data scientists are using this for research papers. The fourth chart that we are going to see is facet grid chart. So specifically in which scenario I'll be using this chart, facet grid. If I want same chart repeated for different subsets of data, which is arranged in rows and columns. So for example, one plot per gender, one plot per region. It will be showing me the comparisons without clutter. So it will be showing me patterns across categories. So for example, if I want to understand the relationship between sales and advertising spent. So based on advertisement amount that I have spent, are there any differences on the sales? If I want to understand that, in that scenario, I could use this chart for understanding what is actually going on. Now let's try to understand the coding part. The first thing is ggplot, which is as similar to what we have used for the previous one. Then I'm giving plus geom point, it adds scatter points. Then I'm giving facet grid, right? Here it is creating a grid of plots. What is this DRB and what is CYL here? Here DRB is about rows are being splitted here by driving type. Then columns are being splitted here by number of cylinder. That is why we call it as CYL. So we are creating a grid of plots based on these two categories. Then I'm giving plus label because I'm just going to give the label and I'm going to create the chart. The label that I'm going to give here is facet grid, drive type versus cylinders because that is what I'm going to analyze and understand here. Look into the lines of coding that I have used and look into the chart creator. It is 10x times powerful than Matplotlib and Seaborn, right? Because we used some 10 to 12 lines of coding for creating a simple bar chart or line chart. But look into the chart here. How professional it is. I could understand so many things. I can take many insights out of this chart. So that is why this chart is specifically used for research papers and most of the professional work. The final chart that we are going to see is theme-based visualization styling. So what is the theme-based visualization styling first of all? The separation of data is happening from appearance, specifically based on fonts, grid lines, background and colors. Here, when I need the theme need to be minimal, I could make it. If I want my theme to be dark, I could make it. So here it is not about the new data. It is more about that clarity and aesthetics. Beautifully, my chart could be very minimal and it could be aesthetical as well. So now let's look into the coding part. This coding is actually not going to create any magical things. It is going to create a box plot actually, but that box plot is going to be very minimal and easy to understand. It is going to be very aesthetical. The first thing that I'm doing giving is ggplot of the same things. Then I'm giving plus gm box plot because I'm going to create the box plot. Then I'm giving theme minimal because it is completely customizable. I want my theme to be minimal because it is going to be used for professional purpose. Then I'm giving plus theme because I could give whatever customizations I need to give. Then I'm giving the customization part here. Then I'm giving legend position is equal to none because it removes the legend. Because the x-axis already shows the class, right? That is why. Then I'm giving axis text x equal to element text of rotation equal to 45. So here, what is that 45? Rotation is equal to 45. What is this coding part? That axis text x is completely a customizable variable name that I'm creating. Then I'm giving element text of rotation is equal to 45 because I want my x-axis label to be rotated in 45 degree. Now, when we see the chart, we can understand what is going on. So it improves the readability. Now it's time to see the chart and understand what is going to happen. So the final part is about giving the label and title of the chart and giving x and y axis. Why we gave 45 here? See, in x axis the label it created, see how it is partially not straight. It is rotated 45 degree, right? So that is why we gave rotation is equal to 45. So I believe you clearly understood how to use ggplot and the types of charts and others, and in which scenario I need to use all these charts. So if you have any doubts, without hesitation, drop them in comments. Bye for now. We'll meet you in next amazing video.